Okay, so today what we did is we had a board discussion about our graphs of our rectangle member metals and our sharp metal, our two unknowns. If you remember from the lab, what we did was we took the mass by putting it on the scale. Then we took a graduated cylinder, filled it up with water, put the pieces into the water, and then we would have seen a rise in volume. And the rise in volume is equal to the volume of these irregular pieces. So what students were supposed to graph was mass versus volume, and the rise, not just the final volume, the rise. So here's an example of one board that we saw today. I like the title, The Relationship Between Volume and Mass. Volume is the X and mass is the Y, and I like how they said the variables instead of the units. They didn't say a relationship between milliliters and grams. Those belong next to numbers. So the variables were mentioned in the graph. If you look at their equation, one thing I would change is this should say mass. And I don't see the X variable anywhere. So there should have been volume in parentheses over here. But I like their units. So for the bars, these things, they got around 6 grams per milliliter, and for the sharp metal, they got around 2.3. We can see that there's some error in their lab because their y-intercepts weren't exactly 0, and if we have 0 volume, we should have 0 mass, so our y-intercepts should be 0. But they're pretty close, and actually these are very, very close to the actual value of these slopes, the density of these two metals. One thing we talked about was error, and I want you to mention this definitely in your conclusion. We talked about how if someone put the wet metal into the graduated cylinder, it would measure the metal and the water, so that would add volume. If we put the wet metal on a balance, that would add volume. Our desks are slanted, so that would mess with our volume a little bit. The balance itself does fluctuate to 0.02, so there's some error in the balance. And let me see what else did we mention? Also, if you didn't dry the cylinder between readings, or if there were beads of water inside and the water rose, that would add water to your volume. So those are all errors that I want to hear in your conclusion. We talked about significant figures and how many significant figures our slope should have, and this group had 5 significant figures. So we talked about how the balance reads to about 4 to 5 digits, right? 2 numbers after the decimal, and your graduated cylinder could read to 3 digits. So if I was going to be a modest scientist, and I was picking between 4 and 5 and 3, I would only do 3 and be modest about my results. So that means this would change to 6.19. Our forever statements look those look backwards on this board. So remember, when you're saying, when milliliters is down here, it's for every 1 milliliter, we have about 6 grams. For every 2 milliliters would be 12 grams. So it should be 1 milliliter here, and this is the number of grams. So again, this should be for every 1 milliliter, we have 2.6 grams. So I would reverse those. And we can see that the rectangle is more dense than the sharp metal. And if you took equal volumes of both, I don't know if you noticed this while you were picking them up, but if we have equal volumes, these actually feel more massive. There's more particle per unit volume. So mass is different than density because we could have a huge pile of these and that would be more massive than this. But if we have equal volumes, the one that's more dense will be also more massive. Now, looking at this board, some students found that they had very similar densities of these two metals, and the conclusion that we came to for these groups is that they took very small sample sizes. They didn't take a nice wide range, and the reason why that gives you kind of weird data is that it's very hard to see a rise in just 1 milliliter. It's easier to see a bigger rise. So if we're going to use this cylinder to the best of its ability, we don't want to use small amounts of a rise in volume. We want to use big amounts. And then this board over here, these people got really low slopes. And the reason why we figured this out is that their axes were actually switched. In order to get density, which is grams divided by milliliters, we need grams on our x, mass on our x and volume on our y. But this group did it the opposite, and they probably had in mind their independent variable because most people did mass their pieces before they got the volume. But we don't have a word for volume divided by mass. One way we can change this density, this number into the density over there, is because the axes are backwards, they sort of have the equivalent of run divided by rise. So if we take the reciprocal of these numbers, we should get the densities at the very first board. So if we take 1 divided by 0.4 and 1 divided by 0.12, you would see that this would give you about a slope of 8 and about a slope of 3. Or excuse me, those might actually be backwards. Those equations might be backwards. But that's fine. So this board was also missing units on the number, and therefore every statement, for every 1 milliliter, we have 2.5 grams. So that's correct. That's probably from a different member in the group, but they picked the equation from another member. I think that's about all that we talked about, so make sure you include all this in your conclusion in your homework questions.